Hello, I'm William Hansen. This is my SPED talk on database design. When I started my senior project, I think I did a lot what everyone did is started writing code. Figured I'd sort out my data as I went. And it worked out, but it kind of didn't. So I had came up, it start, my data started as kind of like a half-baked structure, storing stuff that made sense at the time, but actually didn't. As I kind of went through and I started off with Google Sheets and just was sloppy. Um, I started thinking about database design from classes that I had before and realized it's something I needed and something that's important. So I decided to talk about it today. That's a picture of the Google Sheets data that I started as my first data, kind of like my secondary source now. It's still there, but sloppy, messy. So we'll talk about database today. Um, what is a scheme? What even is it? Basically, it is your plan of how data is going to be structured. Tables and fields and all the data types of how everything connects together. How it actually clipped me is like a blueprint of building a house. You wouldn't start just putting up walls. You want the plans and how it's going to be structured first. Same with database. You want to sketch out how everything's going to be stored together before you start doing anything. This makes everything a lot smoother. Um, so different types of databases. Once you have a scheme in mind, you want to pick a database. There's two. There's the relational database, which is like MySQL. That was kind of the picture I had before on the last slide. Different data types stored in rows and columns, strict structure, everything looks the same. It's super good for consistent data. And then there's document database, like MojoDB, where everything's stored in JSON blobs. It's way more flexible. Each record can look totally different. Good when your data is messy or has a lot of nesting. But honestly, there's what data you use depends on how your data looks. If it's uniform structured, then you go with relational. If it's not, maybe a non-SQL. For my project, I went with MojoDB. This wasn't because I had messy data. I actually had very structured data, but I wanted to work with a no SQL database because I had used a lot of SQL back in before. So it was actually really good. It turned out really well. Now, normalization. This is something that sounds kind of crazy, but is very straightforward. Normalization is basically a set of rules to keep your database clean and avoid storing the same data in multiple places. Normal first normal form, one value per cell. No comma separating lists. It's uh, sits into a single field. Second normal form means every column in the database needs to depend on a whole primary key, not just one part of it. Third normal form means no column should depend on another one non-key column. Like you can figure out if someone's city from their zip code, you don't need both in the same table. Um, reason this matters, and it's pretty simple. The more you normalize, the less you're duplicating data, and the less likely you are to have bugs, something updates. So how I use this in my project. Um, my project is called Pod Return. It's a base business fee. It helps businesses figure out if podcast advertising is worth it for them. It runs after someone runs a calculation on this calculator that's in there. They can submit their contact info as a lead. So it's the lead table that stores their name, email, company, their inputs like budgets and their industry. And there's a flag mark in there for high value, which is based on a benchmark of $2,000 or more. One thing that I had to decide earlier was whether those benchmark data, those CPM rates for each industry, would be in the database or keep it in code. I ended up keeping it in the code because it never changes based on who's using it. So throwing it in the database would have been just complex to add and not useful. This picture kind of shows how it turned out. You saw how the Google Sheets look. This is how it looks, a lot more cleaner and well put together. Shows everything that it needs. It's like optional phone number, and if they want to contact an agency, this is also stored in a admin's page, which you can find in the footer. It's password protected. Super easy to get to, super easy to read, well organized. It was turned out really cool. So things to remember. If there's one thing I want you to take away from this is design your database around how you're going to query it, not just how you're going to collect the data. It's really easy to just mirror your input form into a table and move on. But then when you actually need to pull data out, it is in a useful way. It turns into this whole thing. Like that Google Sheet I showed you before, super easy to set up, looked good, but didn't wasn't practical in the end. Um, After I decided to change it up, it looked way better, way cleaner. So, anyways, every project you build is going to need some data at some point. So hopefully this was useful. William, this is my SPED talk on database and design. Thanks for watching.